Hey everyone, and welcome. Today, we're diving deep inside our own bodies to explore something absolutely incredible, the internal architecture that makes everything else possible, the human skeleton. And believe me, it is so much more than just a pile of bones. It's a living, dynamic framework that's working for you every single second. In fact, let's start right there. So just think about this for a second. As you're sitting there listening to me, what is your skeleton actually doing? I'm not talking about an hour ago or what it'll do later. I mean, right now. Well, it turns out it's juggling at least 6 major critical jobs, and we're going to uncover every single one of them. So here's our game plan for this journey. First, we'll cover the skeleton's main jobs. Then we'll break it down into its 2 major divisions. After that, we'll see how different bones are shaped for very specific tasks. Then we'll take a microscopic peek inside a bone, and finally, we'll look at the joints that connect everything together and allow us to move. Sound good? Let's go.
All right, first up, your body's scaffolding. This is where we're going to answer that big opening question and really see why your skeleton is the ultimate multitasker.
So, what are those 6 jobs? Well, first off, there's support. Without it, you'd just be a puddle on the floor. Then, there's movement, because your muscles need something to pull on. Third, and this one's huge, is protection. Think about how your skull acts like a helmet for your brain. Fourth, your bones are actually little factories, responsible for the production of blood cells. They're also a storage vault for important minerals like calcium. And get this, they even play a role in endocrine regulation, helping to manage your body's hormones. How incredible is that?
And this image right here, this is the blueprint for all of that. This is the amazing framework we're talking about. Every single bone you see, from the biggest to the tiniest, plays a part in those 6 major functions we just talked about. So now let's start breaking this incredible structure down. You know, to make sense of all 206 bones in an adult, scientists basically divide the skeleton into 2 main teams. You've got the axial skeleton, which is your core, and the appendicular skeleton, which is, well, everything attached to it. And what's really cool is how clearly their jobs are divided. The axial skeleton runs right down the middle. It's your skull, your spine, and your rib cage. Its main job? To hold you up straight and protect your most important organs. Then you have the appendicular skeleton. That's all your limbs, arms and legs, and the parts that attach them, like your shoulders and pelvis. Its job is all about moving you around and letting you interact with the world.
Let's get a closer look at that axial skeleton. This is literally your body's central pillar. It takes the weight from your head and sends it all the way down your spine, keeping you balanced and upright. It's the strong, stable foundation that everything else is built around.
And here's the other team in action, the appendicular skeleton. These are the bones that give you motion. They're the reason you can walk, run, pick things up, you name it. This is the part of your skeleton that's all about dynamic, complex movement.
Okay, so we've got the 2 big divisions, but what about the individual bones themselves? Well, it turns out nature is super efficient. There's a bone for every job, and you can tell a whole lot about what a bone does just by looking at its shape.
Yep, those 206 bones are sorted into 5 main groups, all based on their shape. It's a perfect example of form following function, where a bone's shape is basically custom-made for the job it needs to do. Let's check out the main types.
First up, you've got your long bones. These are probably what you picture when you hear the word bone. Think of the femur in your thigh. It's the longest bone in your whole body. These guys act like powerful levers that your muscles pull on to create big movements, like walking and running.
Next are the short bones. You'll find these in your wrists and ankles. They're kind of cube-shaped, and their job isn't about making big movements, but about providing a ton of stability and support in places where we need lots of fine, controlled motion.
Then we have the flat bones, your sternum, your ribs, most of the bones in your skull. These are all great examples. They're thin, often a bit curved, and they act like your body's own personal armor, shielding your most vital organs from harm.
And then you get to the irregular bones. The name kind of says it all, right? These are the oddballs that just don't fit into any other category, like the vertebrae in your spine. Their super complex shapes are very specialized for their very unique jobs.
Okay, so we've seen the big picture, we've seen the different bone shapes. Now, let's zoom in. Way in. We're going to go on a microscopic journey to see that a bone isn't just a solid, dead thing at all. It's a living, breathing, complex tissue. So if you were to look at a cross-section of a bone, you'd immediately see 2 totally different textures. On the outside, there's this really dense, strong layer called compact bone. But on the inside, you find this amazing honeycomb-looking structure called spongy bone.
and both are absolutely crucial.
And here they are up close. On the left, that compact bone is organized into these super dense, circular structures to withstand a ton of force. Then on the right, you've got the spongy bone, with its open, web-like design. This is an engineering marvel. It provides incredible strength, but with way less weight, making our bones both strong and light enough to move easily.
And the secret to that lightweight strength? It's a structure called trabeculae. That's the fancy name for all those little beams and spikes that make up the spongy bone lattice. And they're not random at all. They're lined up perfectly along the lines of stress your bones feel every day. It is just brilliant, brilliant engineering.
All right, we've seen the bones, but, bones by themselves can't really do anything. They need to be connected. So for our last section, let's meet the connection crew, the joints that make all of our amazing movements possible.
When we think about movement, like bending an elbow or waving hello, we're mostly talking about synovial joints. These are the most common type in the body, and they are built for motion. Their secret is a little cavity filled with synovial fluid, which acts like oil in an engine, letting the bones glide smoothly past each other.
And these synovial joints come in all sorts of varieties. You have hinge joints in your elbow, and yep, they work just like a door hinge. You've got pivot joints in your neck that let you shake your head no. Ball and socket joints in your shoulder and hip give you that awesome wide range of motion. There are even plane joints in your wrist for gliding, and special ones like the saddle joint in your thumb and condyloid joints in your knuckles.
And this is a perfect look at the most mobile type of all, the ball and socket joint. You can see how the ball at the top of the femur fits perfectly into the socket of the pelvis. This design lets you move your leg in pretty much any direction, forward, back, side to side, and in circles. It works exactly like a joystick. So, as we've seen, the skeleton is anything but some static, lifeless frame. It's a living, growing, and constantly changing system that supports you, protects you, and moves you every single day. And that leaves us with one final thought. Knowing all of this, knowing that your skeleton is alive, what choices are you making today to help build a stronger, healthier skeleton for all of your tomorrows?